Hello, this is a module for investigation 9, solving exponential and logarithmic equations. So solve the number one, solve each of the following equation for x. Okay, so and then you can use calculator to approximate. Okay, so in order to solving for x, this is actually instead of guessing right now, so it's better to change to the logarithmic form. So in order to change the logarithmic form, you need to solve for x from the exponents, which is you need to make the log is representing the x is from the exponent, the base 3 of the 4. And then you can use a change of the base formulas, which means you can put that as any log, which means the change of the base formula means when you have a log base of x in here, so you can put any base, which is we can use a base 10 or b, so you can put the log of x over log of b, or you can put the ln x over ln b, okay? So this time is I want to use a log of 4 or divide by log of 3, and then you approximately get a 1.262. All right, B, we have to solve for x, okay? So first of all, 17.5 is not a base, okay? So you got to divide by 17.5 both sides. This is 3.4 to the x power. Now you can solve for x, which is a log, and the base is 3.4 of 22.4 over 17.5. But you can just change it as ln of or log 22.4 over 17.5 over ln of 3.4, and then become about 0.202. Now let's look at number 3. In 2009, the enrollment at the mainland high school was 1650 students. Administrator predict that the enrollment will increase by 2.2% each year. So determine when the enrollment the mainland high school is expected to reach 2,600. Okay. So let's make the formula here. So let's get a t as a years. Okay. So starting from the 1650 2009. And then each year increasing 2.2% means 1.022. So increase by each year. But they're looking for the how many year it takes to become 2600. So 2600, 1650, 1.022 teeth. And then solving for the t, so divide by 1650 both sides. I got 2600 over 1650, which is 1.022 teeth power. Now in order to t is log, base is 1.022 of 2600 divided by 1650. And then you can just use any logs you want. So maybe the log of 2600 over 1650 and divide by another log of 1.022. And then I get about 20.9 years. And then B, suppose the mainland high school required a 5 teacher per 65 students. How many teachers are required if the students enrollment is 2600? Yeah, so this is just a proportion, right? So they need a 5 teacher for 65 students. How many teacher they needed it for 2600, okay? So solving for x, so you can cross multiply. So 65x equal to 5 times 2600, and x is actually the 5 times 2600 divided by 65, and then about 200 teachers they needed. Okay. All right, let's look at number 4. Now, we're going to go back to the alpaca problems that the previous investigation. So we called in alpaca problem from the module for investigation 4, a farm in Canada, 218 alpacas on January 1st in 2004. After 8 years, the alpaca population decreased to the 187. Assume the number of the alpacas decay exponentially. So define the function after express the number of the alpaca on the farm in terms of the number of the year of the since then. Okay, so we can say as the formula we used was f of n was 218, and then ratio is becomes 187 from the 218, but that's for the every 8-year growth factor, decay factor, right? But I want to put that as every year, so n over 8. That becomes you can find any of the year right now. Okay, so use the function defined that estimated the alpha class on the 2013. So 2013 is subtract 2004. So this is a 9 years apart. Okay, so now we want to know how many alpha class. So which is n equal to 9 of 218 of 187 over 218 to the 9 over 8. Okay, so it's about 183 alpha class. Okay, which is a 449, but about the 108, okay, the 183. So use the algebraic method to determine the year when the alpaca on the farm was 165, okay? So 165 right now, and then from the 218, 187 over 218 to the n over 8, and then solving for n. So 165 over 218, which is 187 over 218 n to the 8th power. So solving for the exponents, we use a log, which is a basis of 187 over 218 of 165 over 218. And then n over 8 is use a log, which is base of 10, 165 over 218 divided by log of 187 over 218. And then solving for n, I need to multiply by 8 both sides, okay? And then 8 both sides, okay? And then you got n equal to, they're about 14.550 years, okay? All right, number 5. 22 koala bears were introduced to the Wallaby Island in 1928. In 1992, the population of the koala bears on the island was about 2,000. So yeah, increased a lot, right? Assume the population of the koala bear can be modeled by the exponential growth. Determine the annual growth factor in these situations, okay? So starting from the 22, and then it becomes 2,000 over 22 for how many years? So 1992 subtract 1928, which is a 64. So I want to say t over 64 for each year, okay? So use the algebraic model to determine the year when the population of the koala bear on the island will be 4,500, okay? So now the 4,500 koala from the 22 of, so 2,000 over 22 is about 1.073 to the t over, hold on a second. Yeah, I think they just put it out with this one, sorry. So what I need to do is, okay, so here's the thing. Let me change the formula. Oh, sorry about that. So what I do is, I want to compute n22, and then I'm going to compute the 2,000 over 22 to the 1 over 64. So which is about the 1.073, okay? So 1.073. So, and then t-th power. Okay, now I change to the 1 unit growth factor, okay? So 4,500, 22, 1.073 to the t-th power. Now we are solving for t, so 4,500 over 22 equal to 1.073 to the t. So for t, the log, and then you put the base as a 1.073 of 4,500 over 22, and then split the log 4,500 over 22, another log of 1.073 base 10, and it's about 75 years, okay? About 75 years, but it's from the 1928. So if you're adding the 1928 plus 75, it becomes 2003. So about 2003, COLA becomes 4,500. Okay, let's see the number 7. In 1990, the population of the Diamond Bar was 45,000 and population of the Chino Hills was 37,000. In 1992, the population of Diamond Bar was 51,750 and the population of the Chino Hills was 44,400. Assume that both cities' populations growth as the exponential rate. How many years will it take for the population of Chino Hills surpass the population of the Diamond Bar? Okay, so the population for the Diamond Bar and Chino Hills we compare this time. Okay, so let's say we can think about two ways. Okay, so let's say P is the population of the Diamond Bar, and then Q is the population of the Chino Hill. So P population of the Diamond Bar is starting from the 45,000, and then it becomes 51,750 over 45,000 to the years are 2 years, so T over 2. And then for the Q for the Chino Hill, so starting from the 37,000, and then become 44,400 from 37,000 to the 2 years. Okay. So the surpass means actually we need to find the year that the two populations come out the same, right? So I can set up as 45,000. If I change to the decimal to the this whole thing, okay, over 1, right? And then I get about 1.15 to the t, which equal to the same thing here too, 37,000 to the, if I change that to decimal, it becomes about 1.2 to the t power. Oh, t over 2, sorry, t over 2. So keep it just okay. And then so now we're just solving for t this time, okay? So what I need to do is I divide, either way it's fine, but I divide by 37,000 both sides. And then I divide by 1.15 t over 2 both sides. And then you get the 45,000 over 37,000 equal to the 1.2 to t over 2. And then 1.15 to the t over 2, okay? And that means I can change the 45,000. Yeah, so I just keep the 2, okay? So yeah, don't worry about this. Just this one to change, okay? Over 37,000, which is I can put that as 1.2 over 1.15 to the t over 2. And then I'm solving for the exponent. So t over 2 is a log base of the 1.2 over 1.15 of 45,000 over 37,000. And then multiply 2 both sides, okay? So which is a 2 times of the log 45,000 over 37,000 over log of 1.2 over 1.15. And then it becomes about 9.2. So about the 9.2 years, and it will surpass so which is the population of the Chino Hills more than the population in the Diamond Bar. All right, thank you for listening.